Chapter 16, the transistor switch, frequency of operation. As far as BJT or FET concerns, they have also non-linear application besides the application in the amplification kind of. Now, we know that transistor can also act as a switch because it has high and low stage usually corresponds to saturation and cutoff. So these two region of bipolar or JFET is used for digital switching circuit because we need either on stage or the on stage or off the stage. So we have basically three type of circuit diagram over here. The first one is the basic bipolar transistor switch. Second one is the bipolar transistor switch with the capacitance, which is in the time the capacitance passes the voltage changes, so frequent voltage changes are bypassed. The other circuit at the end is a basic transistor circuit, but in order to reduce the noise, we have a VCS applied over here of 2K, so it derives the high level Q point near the origin. Now these are the output and input waveforms for the first circuit. This is the output, that's the input circuit. So we obtain all the way values from the graph. Input output waveform for the second speed capacitance circuit, and these are all the points we get for that. Input output waveform for the final circuit with the application of 2K of RCC. We obtain the similar points, and we will study all detail in the simulation graph. Chapter 8:16, the transistor switching. Now make a 16 transistor a new schematic. Now open a blank project. Now add the components. All the resistors, capacitance, VCC and transistors. Write all the, give the voltage source. Make the changes. Give the ground to the supply VDD and JFET. That's the circuit we got. We'll make a VCC1, 5 volt DC, RC1, RD. Give the supply V1 minus 3 volts, TD as 0, TR as 1 nanosecond, 5 volts, TD as 0, TR 1 nanosecond, TF 1 nanosecond, 1 micro-s, 2 millisecond. That's the supply. Net LER as V input 1 and V output 1. New simulation for 10 millisecond. 4 microsecond, 0.4 second. Copy paste another circuit. Make speed up capacitance in the feedback of RB2. In the time domain, capacitor passes the voltage change, make a copy paste, make a null circuit. So we output 3. That's already. That's the 3 circuit we formed. Change the values as the scene. This is the J3, J1, J2, J3. Give the grounding to J3. Make proper connections are okay. We output 2, we output 3. That's our output alias. Run the simulation, changes in simulations. This is output of first circuit. That's input output curve. So from this we're gonna calculate the storage time, delay time, transition time. That's the storage time. This one. That's the 5 volt. Scroll more. That's the transition time and the delay. So we are finding all those values. Now for the output 2. This is all the current values. Output 2 for second circuit, input and output curve. Now that's for the input side. Compare the graph. Note the storage time. The data started, the transition and the delays. 3 value we're finding. That's the timing we wanna find. It's very tough to find it out. Keep scrolling. The difference when the cursor 1, cursor 2, maximum, minimum, averaging, we find for V output 3, for V output 1, the calculation is attached with the file. Input and output for the third one circuit. Now this one gives you the 0.1 nanosecond. Change the values to 0. Change the values of the parameters. V output 3, input or 3, that's the waveform for the output circuit. For third one, now we're gonna find the timings like storage, delay, and transition. We're going through that. Keep scrolling the windows. That's the timings. Change the values as you can see. V output 3, input and output for third circuit. Access setting 0 volt to 5 volt. change the settings as I'm saying to you. This is a very tough graph. I don't know what to say, but just keep on changing the settings. We need to find the, as per the advanced activity, the calculation is shown in the figure attached or file attached with that. This is the output 3 and input 3. The highest frequency of operation we want to find. Change in value capacitance. Now we want to compare the third part of our advanced activity, comparing the base current between the regular and speedo switches. So this is the regular and speedo switches, the base current. Now make the comparison by comparing the decreasing the scale. So B2 is the regular and B1 is the speedo resistance. That's the two graph we obtained. See the difference.